Hello guys, welcome back to our channel Intense Physics. This is Vamsi, and in previous video or previous episode we have discussed about vectors, the introduction to the resolution also. We have completed. Actually, in a thumbnail I have put like this introduction, like introduction to resolution, but some of you might think that it is introduction to resolution of vectors. No, it is not introduction to resolution of vectors. We have discussed from the starting of the vectors, introduction to vectors until resolution of vectors. So I'll be changing it. I'll be putting from introduction, I'll be putting 2 here. Then you'll be fine with the thumbnail also of the previous episode. In today's episode, as I said, we will be discussing about the parallelogram law. Before that, please excuse me for 1 day delay in uploading the video since I was busy with some work, and also this delay of the day, time. So sorry for disturbing you at this time of really it is nearly it is 9 o'clock when I started recording. Now it is 9 o'clock when I started my recording. I hope it will be available to you on 10:30. Yeah, 10:30 p.m. Sorry for disturbing you at this night. Okay, literally I was busy with my work, so that is why I haven't uploaded the video. But anyways, let us start the video. In the previous video, we have seen the graphical method and analytical method of addition of vectors. In today's video, we will be going to the first parallelogram law. First, we will be seeing parallelogram law of vectors, of addition of vectors generally, but we write parallelogram law in general. Next, we will be moving on to the triangle law. After that, we will be moving on to the polygon law. Until there, our video gets ended. Okay, that is the end of our video, and that is the end of the chapter also. Actually, you have a scalar product and vector product, that is for dot product and cross product. I'll be dealing with it in the motion in a plane chapter whenever it is required. Okay, now it does not come under the introduction. Basically, it is required in the motion in a plane chapter. From there, it is required. So in that chapter, I will be discussing it with you. Okay, guys. Let us start this parallelogram law, and also we have some problems on vectors also. If you want them, please mention in the comment section below. I'll be making a separate video on it. Maybe the next episode. If you ask me about these problems on vectors, I'll be making it as a separate episode. It might be the next episode, the third episode of vectors. Okay, guys. Yeah, let's start with the parallelogram law. Chalo. In the At the ending of the video, I'll be revising the resolution of vectors also. Okay, I'm writing it here at the end. Okay. At the end, I will revise a resolution okay, guys, at the end of the video I'll be revising you the resolution of vectors also. Don't worry if you haven't watched the previous episode. From the previous episode, resolution is one of the important topic, and it is most topic of concern also. Okay, no problem, I'll be revising it once again today. Okay, let us move on with the parallelogram for now. After parallelogram law, triangle law, after that polygon law. Triangle law and polygon law look the same, so that is why today's episode will not be so lengthy. Like, after cutting the revision part, after excluding the revision part, it will be some 30 to 40 minutes of episode, and the revision will be some 10 minutes of some 10 to that also, if I have time only, I'll be doing the revision. Okay, or else you watch the previous episode for a more detailed thing. Okay, uh, some 10 minutes I'll be taking for the revision of the resolution of vectors. Okay guys, let us start without any further ado. It has become more lengthy introduction. Yes, yeah. What does this parallelogram law of vectors say? Where do we use this? We use this actually for addition, addition of vectors. Okay, actually vector is in addition results in a resultant, right? So we use it to find the resultant, find the, okay, I hope you will not be able to see that. I'm moving it here. Find the resultant. Addition of vectors means it is nothing but finding the resultant. We have seen in the previous episode that I have written C bar is equals to A bar plus B bar, or also C bar. Okay, we have used R bar, right, in the previous one. Oh, okay. In the previous one we have used R bar, small R bar. Let me use the same again. R bar is equals to A bar plus B bar, or we have also seen small r bar is equals to A bar minus B bar. Yeah, this one, this subtraction we have converted into addition by putting a plus sign and putting this B bar in brackets. So this one we have seen. What did this R bar represent? What does this R bar represent? It represents nothing but resultant. It is the resultant due to the addition or subtraction of two vectors. Okay, two vectors. So vector addition and subtraction you will not see and find, just not the magnitude for adding. Okay, like 5 plus 2 gives you 7, 5 plus 7 gives you 12. No, this is not vector addition. That is what you have to learn from the previous episode, or from today's episode also. You have to learn that. You have to learn that vector addition does not simply mean just what we know. Okay, it is something else. So what is that something else? Without hesitating, without having that fear of asking anything, do not worry. If you have any doubts, you can place in the put in the comment section below. You have a comment section below which is given, use it for some days. Yeah, okay guys, let us start with the parallelogram law. What does this parallelogram law state actually? This parallelogram law states that if two vectors, say for suppose A and B, A bar and B bar, are represented as the adjacent sides of a parallelogram. So that is what I am showing you. If this is A bar, this becomes B bar. If they are represented as the adjacent sides of a parallelogram, what? What? This is A bar, this is B bar. We have a parallelogram like this, right? This is a parallelogram. If two vectors are represented as an adjacent sides of a parallelogram, say these two, then listen carefully. The resultant is along the diagonal of the parallelogram, which is drawn from the point of meeting of these two vectors. Okay, this is your resultant. This becomes your R bar. Okay, that is what I'm showing you here. Okay, yeah, let me just duplicate this and place it here. We are just constructing an parallelogram actually here. Yeah. Let me show you, wait a minute. This is a parallelogram that we have constructed here. Okay, let us then name this parallelogram O. This is P, this is Q. Okay, not Q, let us put some other terminology, like R we use for resultant, S T. Clear? Clear? T. Now, if two vectors are represented, I am writing it here. If two vectors are represented as the two adjacent sides of a parallelogram, parallelogram, then the diagonal represents resultant. Okay, wait a minute. If you can see this diagram, wait. Sorry, yeah, you cannot see that fully. So what I do generally, I select it. Okay, this video has become too much big. I have to reduce it. I'll be reducing it from the next video. Okay, this is your parallelogram. Where should I place it? I'll be placing it here. Okay, it is fine. And this diagram, I'll be making it also short like this and bringing this here. Okay, this is your parallelogram law. Let me show you the resultant in this diagram. We have taken these two as at the adjacent sides of a parallelogram, this red color one and this green color one, and we have represented two vectors, say A and B, and the angle between them is some theta, A and B are two vectors and the angle between them is theta. And if they are represented in such a way that they are the two adjacent sides of a parallelogram, then the diagonal of this parallelogram constructed shows you the resultant or gives you the resultant. Sorry, yeah, this diagonal. See, diagonal should be drawn. Remember this, no need to write it. Remember that the diagonal should be drawn from the point of meeting of these two vectors. Okay, from this point the diagonal should be drawn, not from this point and neither from this point. No, from this point the diagonal should be drawn, and this diagonal which is drawn, it represents the resultant R bar, which is equals to A bar plus B bar. A bar plus B bar. Now the thing is, we are not interested in this law, what this law says. We are not interested in it. We are not even interested in this R bar also, but we are interested in the finding the magnitude of R bar, which is equals to R. We are interested in the finding of this magnitude of R bar, that is how do we find it? Okay, that is our principal question now. That is the question which is put in front of us now. I am erasing this wall. That is the introduction to the parallelogram law. Now we'll be seeing this R. How can you find this R? So it is very simple for finding the R. Actually, this is not required for your NEET. I can just say that this R is equals to magnitude of R bar is equals to root over A square plus B square plus 2AB cos theta and leave it. But I am telling you the derivation, since you will be understanding it. How does this come? Okay, we have used red, we have used green, we haven't used dark blue. Please excuse me for this yarnings. Yeah, see here, see here. Okay, we have this dotted line, right? Why to use that again and waste the time? Yeah, what I am doing is, now I am extending the line PO. I have extended the line PO and I have dropped a perpendicular from point T onto it, onto this, and this is your perpendicular say for suppose q. TQ is a perpendicular which is dropped and drawn. Okay, if this is theta, if this is theta, this is also a theta, since it is just the extension of it. If this is b bar, this is also b bar. If this is a bar, this is also a bar. Now we are writing that as a magnitude. Okay, if you have not seen there, if you are not able to see there, magnitude of a bar. Okay, magnitude of a bar is equals to a, magnitude of b bar is equals to b, magnitude of r bar is equals to r. These are the symbols and sign conventions you have, not sign convention. These are the symbols that you have to keep in mind all throughout this parallelogram derivation. Parallelogram derivation. These are the symbols. See them and be hiding at the back of my video. When they are necessary, I'll be bringing them. Okay, this is the thing which we have done here. Now what we have to do is, we have to find, this one, TQ and TQ. We have to find both. How can we find this? We already have the trigonometry in our hand which says cos theta is equals to adjacent by hypotenuse. This is also already a right angle triangle which is like this. Consider triangle. Consider triangle. Okay, I'm very bad at drawing, guys, so that was why I take use of these shapes. Consider this right angle triangle PQT. This is theta, this is B. I'm taking the magnitude itself, and this is PQ and this is TQ. Now, from this triangle, you can write cos theta is equals to adjacent PQ by the hypotenuse B. From there, PQ comes out to be cos theta, B cos theta. So this is B cos theta here. In a similar way, I can find the TQ by using the sin theta, which is provided by the same trigonometry. Yeah. Okay, by provided by the same trigonometry, I can use that sin theta is equals to TQ by B. Similarly, TQ comes out to be B sin theta. So this is B sin theta. So similarly, this is the thing. You have to know TQ and BQ. TQ is B sin theta and PQ is B cos theta. Let me just move these two away from here and let me remove those. These are important. Placing them there. These are important. Okay, these are not at all important. So that is how we have find the PQ and we have found out TQ. Are we clear enough? Are we clear? Okay, are we clear? Yeah. So that is how we have found TQ and PQ. Now what we have to do? We have to find the length of this diagonal. We have to find the length of this diagonal here. Oh, it is an eraser. We have to find the length of this diagonal here, that blue line. For finding that blue line, what we can do, we can take this one, right? Yeah, we can take this triangle OTQ. We can take the triangle OTQ. Am I right? Okay, we can take this triangle OTQ. What does OTQ stand for? OTQ stands for a right angle triangle where this angle, say for suppose alpha, this is alpha, this is right angle, this is r bar or r, simply you can say. I'm writing the magnitudes here, I have put already. This is your r, this is your a, this is your b sin theta. Sorry, this is not your a, that is a plus b cos theta. Am I right? It is PQ, this PQ, sorry, this OP, plus PQ. PQ is B cos theta and OP is A. So that is what we have written. A plus B cos theta. Okay. A plus B cos theta. Clear? Are we good to go? And in this triangle, this is your O, okay, QT, OQT, OQT. Yeah, this is your right angle triangle. Now, what we have to do is we have to find or apply the Pythagoras theorem for this triangle. We have to apply the Pythagoras theorem for this triangle. According to Pythagoras theorem, what is that? What is that? Hypotenuse ka square is equals to side 1 square. I am considering this as a side 1 square plus side 2 ka square b sin theta whole square. Now what it becomes? R square is equals to a square. Let us expand this. A square plus b square cos square theta plus 2ab 2ab cos theta. Am I right? Plus b square sin square theta. Okay. From now look at this. Change here. From this term and this term, I can take b square common. So what it happens if I take b square common? It becomes r square is equals to a square plus b square of cos square theta plus sin square theta plus 2ab. Okay, let me write them down. Plus 2ab cos theta. Am I right? This is one according to trigonometric identities and trigonometric identity. Therefore, r square is equals to a square plus b square plus 2ab cos theta. Am I true? Am I very true or not? Yeah. So that is why r is equals to a square plus b square plus 2ab cos theta ka root over a square plus b square plus 2ab cos theta. This is the formula. What is that? It is not the formula, but it is simply the magnitude. A vector can be represented by a magnitude and a direction. We have already found out the magnitude of this vector r bar, the resultant r bar. In order to find out the direction, let us assume this angle as alpha. I have already assumed it. Now for finding the angle, what can we do? We know this adjacent side, we know this opposite side. Yeah, we know opposite side as well as adjacent side. But for placing the hypotenuse, we have this big formula. But we have to find the direction for this hypotenuse only. So that is why what we use the trigonometric ratio, which is containing both the opposite and adjacent sides in it. So what is that trigonometric ratio which contains? It is your tan theta, which is equals to opposite by adjacent. Opposite is what? I hope it is b sin theta. Oh, yeah, I be very true. Yeah, it is b sin theta. And adjacent is a plus b cos theta. So this is your, okay, this is not theta, it is actually alpha. It is alpha. Tan alpha is equals to b sin theta by a plus b cos theta. This is the direction. As per our convenience, or not as per our convenience, as in convention, we are taking direction as the angle between the vectors only, or the angle only we consider as the direction. Am I true? Am I very true? Yeah. So that is why tan alpha is equals to adjacent opposite b sin theta by adjacent a plus b cos theta. Very clear. We have found out the magnitude of this r bar as well as the direction of r bar. This is your direction of r bar. This is your parallelogram law. This is your parallelogram law of vectors. Okay. This is the parallelogram law of vectors. But this is the parallelogram law of vectors for addition. Where r bar is equals to a bar plus b bar. But we also have a subtraction of vectors, right? So what is the thing that we have to do for subtraction of vectors? Nothing much you have to do is that, but we have to put r bar is equals to a bar minus b bar. But we know the trick, or we know the max loophole where we can use this one. We can convert subtraction into simple addition. So we know this trick. But we have to place minus b bar wherever we have placed this b. Wherever we have placed this b, we put minus b bar, and it is b square here. Minus ka square is plus, so plus, nothing change in here, but here it is plus b only, only one b is there, so that is why we have to replace this plus b with minus b. So what we do is the formula remains as it is, but there changes there. A plus a square plus b square plus 2a minus b cos theta. This is a change, and let me put this minus forward. R bar is equals to root over a square plus b square minus 2ab cos theta. This is for what? If R bar, you have to find the subtraction of vectors. Very clear? Very clear? Yeah? Yeah. What is the maximum and minimum values of this theta? That gives you the maximum value and minimum value of this resultant r, from which to which this r can lie. It is not any constant. It is a variable. It varies between two ranges. One, it is a maximum range, second one is the minimum range. What is that maximum and minimum range between which this resultant varies? Those ranges can be found out by substituting values of theta here. We can substitute various values of theta, but we will be substituting some regularly used values which are given in the papers only. And this is which thing is orientation is not the direction. Please do not mislead in this context. This context. If theta is 0, then cos 0 becomes 1. Then R bar is simply R is equals to root over a square plus b square plus 2ab. Yeah. How can I write this? This is equals to R root over a square plus a plus b whole square for का formula है ना. So if this square and the square root go, it goes to be a plus b. Resultant comes out the simple addition of these two vectors. If some force is 3 Newton and some 7 Newton are acting this way, then the resultant of these two forces will become simply 10 Newton. How can I say? If the angle is 0 between them, then I have already told in my previous episode that they are parallel vectors. Parallel vectors. Am I right? If they are parallel vectors, simply you can add them. Okay? Remember this. These two are parallel vectors. If I bring this arrow here, yeah, remember this one. Very simple. Let me erase it. Let me erase this all calculation also. I'll be putting only the value. R is equals to a plus b. Simple. Such simple. If I put theta is equals to 90, which is another frequently used angle, then cos 90 is 0. Then the whole value becomes 0. So R is equals to root over a square plus b square is only remaining. So that is the answer. Root over a square plus b square. If 90 degrees, they both are perpendicular to each other. Next one is 180 degrees. Cos 180 is minus 1. Cos 180 is minus 1. If minus 1 comes, nothing much to change, but it only becomes a minus b. How? R bar R is equals to root over a square plus b square plus 2ab of minus 1. Yeah, I'll be putting this front. So it becomes the formula of a minus b whole square. This is square root and this is square ko cut gaye. Then you remain with this. So that is what I wrote there. If they are vectors are at 180 degrees, then what is the meaning? That is, they are anti-parallel in nature. It is nature of vectors, not orientation. Please change it. Anti-parallel in nature. These are the frequently used angles. Now tell me, sorry, now tell me what is the maximum value of R? A plus B. What is the minimum value of R? A minus B. So simple. If it is A plus B, it is 0 degree. That means they both are parallel in nature. If it is minus A minus B, then it is 180, which means they both are anti-parallel in nature. Very clear? These are the minimum and maximum values of R. Okay? Okay? Yeah? No. If equal vectors are given, okay, if A is equals to A bar is equals to B bar, then find R bar. Simply we know that R is equals to, okay, remove bars, this one. We know that R is equals to root over A square plus B square plus 2AB cos theta. Here A is equals to B, so substitute B or A in place of B or B in place of A. Anything is right. I am substituting A in place of B plus A square plus 2A square cos theta. Am I right? This is root over 2A square plus 2A square cos theta. If I take 2A square common out, it becomes root over 2A and in the bracket 1 plus cos theta ka root. Yeah, yeah, am I true or not? Yeah, 1 plus a cos square, 1 plus cos theta is a trigonometric identity where it is equals to a root over 2a into root over 2 cos square theta by 2. This one, 1 plus cos theta is equals to 2 cos square theta by 2, and 1 minus cos theta is equals to 2 sin square theta by 2. That you have to remember. These are the two trigonometric. I have introduced total 3 trigonometric identities where sin square theta plus cos square theta is equals to 1. 1 plus cos theta is equals to 2 cos square theta by 2. uh, 1 minus cos theta is equals to 2 into sin square theta by 2. You have to remember these 3 identities. You have to remember them. Okay? Okay? From here, if I remove this cos square out, it total comes out to be this one, root 2 into root 2 is 2. A cos square means cos theta by 2. This is your resultant if two equal vectors are mentioned and the angle between them is theta. And you have to do A plus B. A plus B condition. What is this? Oh, this is this. A plus B condition. Let us talk about A minus B condition. If it is A minus B condition, we only know one thing to do. We only know substituting minus in place of plus. If I substitute minus here, then it becomes 1 minus cos theta. What is 1 minus cos theta? It is 2 sin square theta by 2. So therefore the answer becomes R is equals to 2A sin square theta by 2. Simply, simple, such simple it is. It is very simple, very simple. Okay, this is your parallelogram law. Let us check how many minutes this parallelogram law takes. I'm sorry guys, that parallelogram law only it has taken 30 minutes, 34 minutes. So it takes another 20 minutes in order to complete the triangle law, okay, and polygon law. See, both are little similar, the triangle law and parallel polygon law. Nothing, they say nothing actually. That is, if you represent two vectors as the sides of the triangle in the order, then it resultant is the sorry, the other side which is remaining unclosed becomes closed by the resultant in the opposite order. If you take this order as an anti-clockwise direction this way, then the resultant closes this unclosed side in the reverse order. That is, if you take the both the vectors in this way, the anti-clockwise way, the resultant comes out to be in the clockwise manner. So that is what this triangle law states. Or else you can also, it can also state that if three vectors are represented as the three sides of the triangle, then the resultant or the sum of these three vectors comes out to be 0, comes out to be as 0. This is what triangle law says, and that is the same thing that the polygon law states. If you take any polygon, if you take any hexagon, heptagon, octagon, nonagon, decagon, if you take anything and if you put only one side remaining, I'm telling you the first definition, then that unclosed side is closed by the resultant in the opposite order which you have taken to the vectors. Okay, if you want to write it in other way, all the sides, if all the if vectors are represented as all the sides of the polygon in an order, in a single order, then the resultant, or you can say the sum between them becomes 0. The same way that the triangle law states. How this is becoming 0? If you take triangle law, I'll be explaining you this based on the triangle law, and we can complete the video with one sum. Okay, one sum, and just a recap of the previous thing. Yeah, see, I'll be telling you this, I have to tell you this. If this is a triangle, take for suppose I'm choosing this triangle and I'm representing three vectors, a bar, b bar and c bar on the sides of this triangle. I'm taking the first definition. Okay, if that is your a bar, this is your b bar, and this is your c bar. So what does the second definition state? The second definition states that if 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 at all three sides of the triangle are represented by three vectors in order, I'm following the anti-clockwise order here, then the sum between or the resultant between them is 0. What did the first thing state? If two vectors are represented as the two sides of a triangle, then the third unclosed side is closed by a resultant in the opposite order. So this pink color one is your resultant, this pink color one is so your resultant. Yeah, and the resultant and c bar are both in opposite directions, they both are anti-parallel, they both cut each other, therefore the thing comes to be 0. And the same thing happens if you take a polygon also. If you take a hexagon, nonagon, decagon, any gun, any polygon, then the side which is unclosed will be in one direction and the resultant will be in its opposite direction, and this resultant is equals to a bar plus b bar. A bar plus b bar is equals to r bar, and this a bar plus b bar, if you put r bar plus c bar, which gives you 0, since r bar and c bar both are anti-parallel vectors. So the same thing happens in the polygon law also. This is how this 0 comes. This is how this 0 comes. Okay. One of my very favorite question which I am giving to you. I hope you have understood this parallelogram law and triangle law and polygon law of vectors. If you have any doubt, you can post it in the comment section below. I'll be responding to it. One of my very favorite question in this from this topic is that if I represent, okay, let me, if this is a particle, oh, what is this? Okay, if that is a particle and it is being pulled by four forces, F1 bar, F2 bar, F3 bar, and F4 bar. It is being pulled by these four forces and it is at equilibrium. It is at equilibrium. Yeah, battery. My charging is also getting discharged. Mic is also equilibrium. This is the in equilibrium. Okay, I cannot revise that resolution. Please do not worry, guys, since mic is discharging very fast. So that is why I have to complete this. It will not, there will not be time sufficient for that. No problem. Please adjust for this one. If it is an equilibrium, then F1 bar plus F2 bar plus F3 bar plus F4 bar will be 0. Equilibrium meaning है तो ना, it will be at rest, it will not move anywhere. But if I disturb the equilibrium by removing this F4 bar, then what is the acceleration of the block? Find the acceleration of the block very fast. If I remove F4 bar, then find the acceleration. Acceleration is equals to mass, force by mass. Here force is what? These three are the forces. F1 bar plus F2 bar plus F3 bar. Force by m is equals to acceleration. I know you cannot see there, so that is why let me move this. This is your acceleration. This is your acceleration. But we know that F1 bar plus F2 bar plus F3 bar from the polygon law of vectors, we know that that is equals to 0. And if I move F4 bar to that way, F4 bar to that way, F1 bar plus F2 bar plus F3 bar becomes what? Minus F4 bar. And if I put this minus F4 bar here simply, the answer comes out to be this. See this magic, see this wonder, even though there is no F4 there, the acceleration is due to that F4, that removed F4. Why minus? If you just substitute the magnitude, it becomes F4 by m, which is equals to E. So that acceleration of the particle is coming due to that removed force F4. Okay, see that magic. So that is why I like this sum pretty a lot. Okay, please watch the resolution of vectors from the previous episode because mic is so fastly discharging. If I start also, I'll be stuck in the middle, so that I cannot complete fully. So that is why I'm not starting at all. Please look at that video and learn the resolution of vectors. If you have any doubt, please do not hesitate to post in the comment section below. This is Vamsi signing off from Inside Physics. Thank you guys for watching my video. Thank you. Bye bye. Have you a great day further.